In this video, we're going to show you how to calculate molar mass and density at STP using our shortcut. So I'm going to set up a problem here. So here's my problem. 10 liters of unknown gas weighs 31.86 grams at standard temperature and pressure. That is the critical part of this. Calculate the molar mass. So I write down what I know. The volume equal 10.0 liters, and the mass equal 31.86 grams, and I want to calculate molecular weight, which will have units of grams per mole. I just don't know what the value is. And I also know, since it's STP, that I have as conversion 22.4 liters equal 1 mole for any ideal gas. So this is the trick right here. I'm going to convert the volume to moles. And so I take 10.0 liters, divide by 22.4 liters per mole, and that tells me how many moles of gas I have since I'm at standard temperature and pressure. When I do that, I get 0.4464 moles of this gas. And now it's real simple. I just take the mass over here and divide it by the number of moles. So the molar mass, molecular weight is what I use a symbol of, is 31.86 grams divided by 0.4464 moles, and I get a mass of, or molar mass of 71.37. Okay, so that's pretty straightforward. I'll do another problem or two here of density. And so here's my problem. I'm going to calculate the density of the following gases at STP, and I'm going to do this from the molar mass, which is not given to you. You have to recognize that the molar mass, it can be looked up in the periodic table. So I know the molar mass of argon, it's 39.95 grams per mole, and all I have to do is multiply by 1 mole equal 22.4 liters, and I do that for every one of these. Krypton is 83.80 grams per mole times 1 mole per 22.4 liters. Xenon is 131.3 grams per mole times 1 mole, 22.4 liters. And here I have radon. I wrote it down, 222 grams per mole times 1 mole over 22.4 liters. So when I do the math on these, for the argon, I get 1.78 grams per liter. Krypton, 3.71 grams per liter. Xenon, 5.86 grams per liter. And radon, 9.91 grams per liter. So the point, one of the points you need to take home is, as the molar mass increases over here on the left, the density over here on the right increases. Okay, and this kind of explains why radon, which is radioactive, is a problem. It collects in low places because it's a very dense gas. So it collects in your basement, etc. if you have radon. If it was very light, it would just dissipate into the atmosphere. Okay, so those are a couple examples of how to do these calculations. Remember, if you're at STP, you can always use 22.4 liters equal 1 mole.